Okay, good morning, good afternoon, good evening. Welcome to today's Siemens Global webinar. Today's topic will be looking at discrete manufacturing is on the move. I'm delighted to welcome as your speaker today Mr. Dave Snyder, who obviously works for us here at Siemens Digital Industries Software. He has, amongst his accolades, Masters of Business Administration from the University of Cincinnati. He has over 35 years of advanced scheduling experience. From 2013 to 2016, he was pre-actor leader for North America, and from then till now, he's a MOM channel sales executive. So very warm welcome to Mr. Dave Snyder.
Today's webinar is on why APS brings fast and tangible benefits to mid-market manufacturers. What we're going to do is we're going to look at the challenges and the impact of digitalization in the discrete industry. Then, why and how APS can help in that context, and what does Siemens have to offer? Over half of the companies on the Fortune 500 in the year 2000 have now disappeared. Why? Because of the disruption of digital. What is going on? Forecasts show rising demand for machine products through all end-user industries, from internal and emerging markets. This is true for both low-volume, high-complex products, high-volume, low-complex products. Moreover, most of these products are based on new technologies and innovative materials, pushing the introduction of more flexible machine tools, which must be managed with flexible processes. The higher market demand triggers the need to invest in capacity expansion with new machines. These new machines necessarily bring along new technology and thus the need for resources with different and more sophisticated skills. This makes the overall environment more complex. Higher market demand triggers an increased need in synchronized main assembly lines with supply chain to avoid disruptions at assembly lines. Higher market demand triggers increasing capital costs, and growing pressure over declining margins due to continuous price increases of raw materials, along with the downward pressure on finished goods price due to competition from the emerging markets. This implies the need to, 1, replace disparate departmental systems and processes to efficiently utilize machine capacity, manpower, and material. 2, increase consistency of information across the business. And 3, replace labor-intensive manual processes, which are expensive, prone to error, and slow, with automatized operations as a solution to reduce costs. In mid-market relationships, the vendor-supplier are close and collaboration happens in traditional ways without an IT interface. This means that the customer has a high level of influence on production capability to serve the right customer at the right time to highly challenging and needs frequent adjustments. On the other hand, the demand for predictability has increased. It's increased the need to invest in communication between IT systems and machines to provide full visibility on production status and capability. Then, global higher standard requirements are forcing new levels of innovation for engineering and manufacturing to meet governments, legislations, and industry-specific regulations. There's an increased validation procedure complexity. Manufacturers will revise their strategies and adopt more parameterization from top down, from product to components, increasing capital costs. Higher investments in capital are needed due to technological innovation linked to certifications. These sources of pressure are generating a lot of big questions for our customers, and we, as solution providers, are familiar with these concerns. Again, here we want to stress that we know all of these issues since we have a clear understanding of the market and we're familiar with them. What we can do for manufacturers is support them in transforming these challenges into opportunities. Another interesting point of discussion can be found in this annual report from PwC, the second largest professional and consultant services firm in the world. Trends are showing, in this case, for the automotive market specifically, that automakers and suppliers that do not want to sit out the industry transformation should do the following: prioritize agility, launch fast, learn fast, adapt fast, faster than ever before. Focus should be on capacity management and in using market intelligence and analysis to manage production on a day-to-day basis. Manufacturers need to have inventory and sales data systems to measure supply and demand and to tailor their production accordingly. The path from being capable to managing capability and to adapting fast leads to very quickly to the need of being able to schedule your production on a frequent basis. Sticking with the automotive market, we can demonstrate how this path has already been chosen by some of the leading companies involving their entire supply chain, serving the supply chain as well. VW invested $60 billion to introduce a full modular approach into their car design and developed a shared modular engineering strategy called MQB, Modular Kosten, translated from German to Modular Transversal Toolkit or Modular Transverse Matrix, allowing them to virtually assemble any car on any production line around the world. They developed a standardized, interchangeable set of parts from which it is possible to build a variety of cars that are quite different from each other. The result of this platform adoption is a massive cost savings reduction in the complexity of design of production and an increase in flexibility. The adoption of these types of strategies has an enormous impact on the supply chain and scheduling. Consider, for example, that with MQC, you can produce Audi, Seat, and Skoda in the same facility. This requires, of course, a very sophisticated capacity of scheduling. And we can say that the market and the companies with it are moving in a direction that is triggering deep interventions in the capacity of scheduling. By adopting this strategy, VW expects to reduce car manufacturing time by 30% and, of course, save a lot of money as well. Recent market analysis indicates the following top three pressures that discrete mid-market manufacturers perceive as drivers for production process improvement. Higher demand. Forecasts show rising machining product demand through all end-user industries from both internal and emerging markets. Flexibility. The market is quite dynamic in terms of product lifetime, which is getting shorter and shorter with smaller production lot sizes. Manufacturers need to be able to change production type frequently and efficiently. And predictability. Both buyers and vendors need to have increasing realistic visibility of the execution date of an order to be able to play their role in the supply chain. From our experience talking with hundreds of manufacturers, these are the top challenges that companies complain about. Difficult to maintain high level of service, lowering stocks and shortening production lots, time consuming to generate and analyze alternative production scenarios, limited ability to make better decisions, complex to balance and synchronize demand, supply, and capacity, large number of setups and low production efficiency, difficult to react quickly to unforeseen changes. So how does APS help and why? Let's face it, scheduling is difficult. It's not uncommon to have 100 items to schedule. But let's not think about 1,000 items or 100 items. Let's simply think of how many ways you can sequence 5 items on one machine. 120 different possibilities, even before adding constraints, material, human resources, and etc. Okay, now what if we double the number of lines that we're scheduling? Again, just 5 items. Now the possibility jumps to 14,400. You can see that when you have even a small order set of just 50 items with material constraints, labor skill sets, in addition to machine capacity, it becomes a complex problem. And if you throw in multiple KPIs, such as minimizing setup time while maximizing customer service, it's a complex problem. In order to achieve best-in-class results, a synchronized and closed-loop process between customer orders, production scheduling, and manufacturing execution is recommended. A real-time scheduling tool is a core element of any lean and agile digital manufacturing strategy for higher process flexibility, precision on-time delivery, inventory reduction, and efficient production. We can see from this slide how APS affects all the value drivers of companies who have already reached a complete digitalization maturity or are along this path. Here's the compass commonly adopted to map the value drivers related to Industry 4.0 vision. Along with a qualitative analysis, there's a more quantitative view on these benefits that are coming from our customers. 27% improvement in productivity, 22% reduction in cycle times, 24% reduction of WIP, 53% reduction of raw materials inventory. Of course, these numbers are averages and differ a lot depending on the level of maturity of each customer. Production scheduling is key to gaining a competitive advantage in the age of digitization. And production scheduling is linked to your other efforts to gain a competitive advantage. How does using APS compare with using spreadsheets? Spreadsheets may work fine in a static environment, but an APS allows you to respond more quickly when there are disruptions to the plan or you're experiencing variation to your typical inputs. How does using an APS compare with using ERP scheduling tools? It's not uncommon for ERP scheduling tools to be based on infinite capacity or have the ability to specify a finite capacity constraint only on one resource, for example, equipment or labor. What does Siemens offer? Siemens offering is a part of the Digital Enterprise Suite, a comprehensive collection of integrated software suites that go from the product lifecycle management to the automation based on the Team-centered collaboration platform. Our PLM solutions like NX, Technomatics, or our new SimCenter portfolio weave the necessary digital thread along all phases of development and manufacturing. Totally integrated automation enables seamless horizontal interoperability between automation technologies and vertical data integration from the field to the enterprise level. MOM, with OpsCenter Suite, is the real-time software layer that links PLM to automation, connecting the virtual world of product development with the real world of production. MindSphere, a cloud-based open IoT operating system that lets you harness the big data from billions of intelligent devices, enabling you to uncover transformational insights across your entire business. Let's see in detail what this means for OpsCenter scheduling. Natively integrated with Siemens MOM products and Siemens PLM products in a closed-loop manufacturing integration approach, it can easily be integrated with ERP and any MOM systems. It keeps your system up to date in order to react efficiently to unexpected changes in demand and capacity. Manual or automatic updates of operation production status. Schedule recalculation. When we talk about planning and scheduling, it can be confusing as they mean different things. We have a planning product that looks out longer, looks at bucketed time, and tells you where your demand will exceed your current supply in specific time periods. The scheduling tool looks at a shorter time frame and determines the actual sequence of specific orders based on all the manufacturing constraints that exist. So now let's jump into a demonstration of advanced scheduling. OpsCenter scheduling has a number of tools for visualizing the schedule. This tool, it's the primary tool that we use. We call it the Gantt chart. Essentially, it's electronic planning board. On the left, we see the resources being scheduled. Across the top is our calendar. The hashed out area is weekend, lunch, evenings. So the white part is our available time. One of the first things I notice is I've got available time here that nothing is scheduled on the piece of equipment. Not very efficient. Why might that be? Well, if I look here, I see I've got these other constraints. And if I drag my mouse through the plot window shows me how many operators are being used. And down on the Gantt chart, I see which operations are using an operator or a supervisor. So very quickly I can tell that these constraints are preventing me from maximizing the efficient use of my equipment. Now what I could do is I could disable those constraints, reschedule, and now I see a more compact schedule. But to get that compact schedule, I would need 7 operators. I'd need 2 supervisors. I don't have 7 operators today. I don't have 2 supervisors available. I could use this as a what if, looking out 6 months and say, if I trained additional operators on a specific skill set, how much more throughput could I get through my shop, or if I trained up another supervisor? In the short term, these are fixed. So I'm going to return my schedule to where it was. Next thing I notice in my schedule is I've got a visual indicator indicating that this order is going to be late. Why might that be? Well, what I'm going to do is I'm going to change the priority of this. And I'm going to reschedule everything, see what happens. Now I see that order is at the beginning of the schedule, and it looks like there's no adverse impact to my having pulled that order forward. There's no offsetting orders that are late from my pulling that order forward. But let's say customer service gives me a call, and you know what customer service wants. Customer service never calls me except when they've got a hot order they want to insert into the schedule. So while customer service is on the phone with 3 key clicks, I'm going to create a what-if order, and I can tell customer service that 14 days from now, that order can be ready to ship. But of course, customer service wouldn't be calling me if the client or the prospect was going to be happy with 14 days. So they're pressing me to get this out the door as quick as possible. So again, I'll change the priority of this, reschedule, and now I reschedule everything. Now that order is at the beginning of the schedule, but I noticed that orders 006 and 007 are now both going to be late. I've got another tool for visualizing this. It's the trace chart. And I can pull up a comparative schedule. I can pull up where my schedule was at before I entered that what-if order. And the green background was the before, the white background is the new option. I can see order by order what the difference is in doing this what-if scenario. And while customer service is on the phone, I can tell customer service what the impact is of taking this hot order. Next, I receive a call from production. Production tells me that the lathe is down. Now, I don't know how long the lathe is down. Production is telling me it's going to be back up in 24 hours. So let's model that. Let's assume that it is going to be up in 24 hours. Now it looks like a red brick wall of downtime for the next 24 hours on the lathe, and it pushed everything else out on the schedule. So if I zoom in on my schedule here, I see that this ABC order is not going to be off the lathe for 24 hours, and we were expecting it to be starting on the drill 8 hours from now. Obviously, that's not going to happen. So what I can do is I can say repair my schedule, put it back in sequence, and it pushed all the other operation steps out and pulled other things forward into the available time. So again, very quickly I can adjust to disruptions, whether it's in demand, on the shop floor, maybe someone calls in sick. Next, next scenario I'm going to use case that I'm going to show you. This is a manufacturer that has 4 vats. Now they could be making metal shavings or coatings, but let's think of it as if they're making paint. If I schedule using the same simplistic scheduling rule, forward sequence by priority, I can tell just looking at my schedule that it's not very efficient. Now the first thing I notice is I got gaps of time here where nothing's being made in VAT 2. Why might that be? Well, again, I've got these other constraints. Each product type has a different rack type, and some of these rack types are a scarce resource. Something else I notice about my schedule is these black bars. These are cleanup times, and I notice that my cleanup time going from white to black is small, going from black to white is large, so it's sequence dependent. And I can quantify my non-productive time. I've got 2.5 days of non-productive time. But if I were to use a more sophisticated scheduling rule, now I see a much more efficient schedule. I can tell that just by looking at it. It still may not be optimized. But if I take a look at the statistics, I've now gone from 2.5 days to 3/4 of a day of non-productive time. And now the last case I'm going to show you is a bicycle plant. This part of the plant we're assembling components, hubs, wheels, pedals. Here we're cutting the bike frames. Here we're welding the bike frames. Then we've got the painting cell, and then final assembly. So if I take a look at my bicycle assembly, I see that it's linked to work orders for the bike frame, the wheel, the pedal assembly. And also, up above I see my purchase components. If the diamond is off to the left, then these are components that are already in inventory. But if it's off further to the right, these are components that we're still waiting for them to arrive. We've got the purchase order. And let's say a supplier calls and says they're going to be 1 day late in delivering their material. Now we see that this shows up out here in the future. Now, to be clear, the supplier is not going to call the planner, and it's not going to be keyed into the scheduling tool. We're just simulating what's going to happen. The supplier is going to call purchasing. This information is going to be entered into the purchasing system, and then that information flows through the normal data flow into the scheduling tool. And when it does, then we see that our purchase material, this material is out here in the future, and we got this visual indicator telling us that this operation is on the schedule too early based on the material availability. So again, I could say, reschedule, repair my schedule. It pushes out the subassembly, which then forces the final assembly to be pushed out as well. And what I could do is I could lock my final assembly, remove everything else from the schedule, and then schedule using backwards schedule based on priority. And it will then schedule my components and subcomponents just in time for the final assembly. Now I've got another way of viewing my relationship with the subcomponents and the materials. It's this bike, work order for the bike. It's 25 bikes are being produced, 15 are going to the sales order, 10 are going into inventory. On the input side, I got saddles, bike frame, wheels, pedals, and if I double click on the wheel, it shows me 165 wheels are being produced, going to 4 different work orders for bikes. And again, I see hubs and rims are being assembled internally. Purchase parts for spokes and tires. I could drill backwards into hubs as well. And I can just see where my shortages are, what my inventory level is going to be over different time periods, etc. This is just some of the tools that we've got. The scheduling tool and change swap. There we go. What are the benefits? What's the value proposition of Op Center APS? Well, thanks to the heuristic rules, it is capable of executing in minutes what other systems require hours, without, of course, talking about manual tools where, like Excel, where things are not even manageable. This allows not only the ability to quickly prepare the initial schedule, but also prompt reactions to whatever disruptions occur. Management is supported by a graphical tool and can identify potential problems, cause and effect, and fix them before they actually happen. It frees up the planner's time for other tasks, preventing issues rather than fixing them. The solutions honor all the constraints. 9 months after implementing Op Center APS, you won't find the planner having to return to Excel because the resulting plans from Op Center APS aren't accurate and reliable. Doesn't happen. You can start small and then grow with an agile approach. Well, sorry about that. The price is competitive. Op Center APS has a 25-year track record in every industry with over 250 case studies generated. What do our customers say about Op Center APS? We increased the level of service, we reduced inventories, we shortened production cycles, we increased productivity, we improved interdepartmental communication, and we reduced stress. And that's not just the planner's stress, that's the workers on the shop floor, because they're no longer receiving calls at 3 o'clock on a Friday afternoon telling them that they're being asked to work overtime because the supervisor just realized that behind schedule on a particular order. With the right tools, you're going to know well in advance and you're going to be able to solve that before you get in trouble. Thank you very much.